Hello, pre-algebra students. This lesson video is going to be on combining like terms. It is our second lesson in Unit 2. So yesterday's lesson, we introduced variables. If you remember back to yesterday, variables were those letters we saw that can represent an unknown number. We are going to continue working with variables today in this lesson. To get us started, I've got a warm-up question for you here. If you're taking notes at home, I also have the name of today's lesson. It's Combine Like Terms. You can also title your paper with that. I encourage you to go ahead, pause this video to try the warm-up question, and then come back to see how you did. So the warm-up question asks the question, how much total money did Tika make? We're told did Tika save? She put $10 in her piggy bank 3 times this week. There's 2 ways you can approach this problem. You can think about it as an addition problem. She put $10 in her piggy bank the first time. She put $10 in her piggy bank the second time, $10 in her piggy bank the third time, and we could add them all up to find that total of $30. You can also think about this as a multiplication problem. She put $10 in her piggy bank and she did that 3 times and used multiplication to get $30. Either way, we're getting $30 as our answer, but I really want to point out here that there's 2 ways you can approach the problem, and there's this relationship between addition and multiplication. Both of them help us solve this problem. This problem was not chosen at random. This is also where we're going to be starting our lesson today. Our goal for this lesson is the following. We are going to talk about how we can simplify by combining like terms. We have heard this word simplify a lot in math. We've talked about simplifying fractions sometimes, simplifying ratios, and now we're moving on to this idea of simplifying an expression. Simplify, if you remember, is this idea of making something simpler. It's this idea of taking something that's more complicated or maybe a bigger math problem or with fractions, bigger numbers, and breaking it down to make it smaller and more easy to work with. And we are going to simplify by combining like terms. Now, these words like terms, that's new vocabulary we're going to learn in this lesson, but you know what combining is. It's putting stuff together. So we're going to simplify and make problems easier today by combining stuff. As promised, I said that warm-up problem was not chosen at random. We were going to use that to help us get our lesson started. So notice here we've got a similar problem about saving money in a piggy bank. But this time I've changed the story a little bit. We've got Sarai is trying to save to buy a TV and puts money in her piggy bank to help her save. She puts the same amount of money in her piggy bank 3 times this week. You'll notice this time I didn't give you as much information. I told you she's saving some money in her piggy bank and she's saving the same amount of money 3 times, but I didn't tell you how much money that is. This goes back to our lesson from yesterday. Again, I'm going to ask you to pause the video and see if you can write an expression to represent how much total money she saved. Because we don't have all of the information in the story, there's going to be something you need here. Go ahead, try this problem now. So I was hinting at, because we don't have all of the information and some of it's unknown, we're going to need a variable for the situation. I told you she's putting the same amount of money in her piggy bank, but since I'm not telling you how much money, and we don't know how much money she puts in each time, that's an unknown, and I need a variable for that. Maybe I use the letter S to represent that money. Remember, you can use any letter you want, but I'm going to say the letter S represents the amount of money she saves each time. Each time she goes to put money in her piggy bank, there's that dollar amount that I don't know, and we're going to call that S. If we think back to that problem about Tika, that's really similar. It's that $10. Here, I'm representing it with the letter S since I don't know how much that dollar amount is. Also similar to that problem about Tika, there's two different ways you can think about this problem. There's two possible expressions. That first way we did the problem earlier was with addition. We said you could add that $10 plus $10 plus $10 to get the answer. One way you could write your expression for this is by saying S dollars the first time plus S dollars the second time plus S dollars the third time. This is one expression that represents the total money Sarai saves. But just like before, there's a different way you could think about this. You could use addition. You could also use multiplication. We could say she's depositing S dollars and she's depositing that S dollars 3 times. So I could say I want to take S and multiply it by 3. Now, one of the things we learned yesterday is when you're talking about multiplying variables, you and I know what we just meant when we wrote S times 3, but this isn't how you're going to see it most often. When it comes to multiplication, you're going to see that number and variable right next to each other, and the number always comes first. So a more common way of seeing this is by writing 3S. That means 3 times S. So I'm going to change that for S. Both of these are correct expressions to represent the situation. We could add S plus S plus S to get that total amount, or we could multiply S by 3. And since both of these are correct ways to represent this situation, I could also say these two expressions are equal. S plus S plus S is the same thing as 3S. Now, I've chosen this problem to help highlight what we're going to be doing today. One of the things we are going to be doing today is taking expressions like this one on the left with S plus S plus S and simplifying it to be something like 3S. Looking at this problem, just like when we did it with numbers, we said using addition all the time isn't always the easiest or the fastest, and that using multiplication is simpler. It also looks simpler. Here, it wasn't too bad because she only saved money 3 times this week. But think about what if this had been 7 times? I could write S plus S plus S plus S plus S plus S, 1, 2, 3, 4, 5, 6, 7 of them. Or we could just say that's the same thing as 7S. What we're doing right here is what today's lesson is on, which we call combining like terms. Now, when it comes to variables and adding them together, you can't just add anything together. And so keep watching this lesson so you can learn a little bit more about how we can do these problems you're seeing on the screen. I want to start off with some vocabulary to help us as we talk about this lesson. So using that same example from earlier with our S plus S plus S is the same thing as 3S. We have learned all of these S's are called variables. When we're looking at an expression that has lots of different parts, like this one right here, each part of our expression, and those can be variables, it can be numbers, but each part of that is called a term. Today's lesson is called combining like terms, so you know that word term is going to be important. The other vocabulary word we're going to use a lot in this lesson is this next one, and it's the name of the number in front of a variable. We've learned that number right there, that 3, it means multiplication. It means we're multiplying 3 by s. That 3 has a name, and we call that 3 the coefficient. 3 is the coefficient. I encourage you to pause the video to get the rest of this into your notes before you move on to the next part, because the next part is going to be some quick practice problems to help you use this vocabulary. So to start, we're going to practice with that word term. I've given us some different expressions for numbers 1 through 4, and my question is, how many terms are in each of these expressions? The key to identifying terms is terms are always going to be separated by plus or minus signs. So for example, if I come back here, notice all of my terms here are separated with plus signs. If I look at number 1, there's no variables here, but we still have terms. I know that there is 1, 2, 3 terms in this problem, and I found them just because I'm looking for the different parts of our problem that are separated with those plus or minus signs. So for number 1, I could say there are 3 terms. I did number 1 for you, but I want you to go ahead and try numbers 2, 3, and 4. It's important to get this practice in to help you be ready for the rest of this lesson. So go ahead, pause the video now and try number 2, 3, and 4, and then come back to see how you did. All right. For number 2, I'm going to do it the same way I did number 1. I'm just looking at my problem and finding the things that are separated with plus or minus signs. So for number 2, there are also 3 terms. For number 3, 2b together is one big term. 3b is together in one big term. I know they're together because remember there's no plus or minus sign between them. They're touching, so they're together. So this one here just has 2 terms. And continuing with that, how many terms did you say number 4 had? Well, we said a big important part to this is terms are separated with plus or minus signs. Notice number 4 has no plus or minus signs. So for number 4, this right here is one big term. That is just one term right there. In order to combine like terms, it's really important that when we look at an expression, we see where those terms are and we know what is together and what can't be separated and what is separate. Now, the extra step to this is number 5. I'm asking you to come up with an expression. So number 5 says, can you write an expression with 4 terms? Go ahead and try that. As you're writing your expression with 4 terms, there are many correct answers for this. Remember, terms can be numbers, like in number 1. They can be variables, like in number 2. Terms can have a number and a variable together, number 3. And terms can have multiple variables, like in number 4. So for example, my 4 terms, maybe I've got a number, I've got a variable, I've got a number and a variable, and I've got 2 variables. Those could be my 4 terms. And then the other important part, remember we separate them with addition or subtraction. So I would just need to come through and put some plus and minus signs there. Right here, I have an expression that has 4 terms. What does yours look like? Hopefully something similar to this, where we've got 4 different pieces, and then you've got 3 plus or minus signs in it as well. At this point in the lesson, I'm hoping you're feeling a little more confident on what a term is. There was that other new vocabulary word we had, which is coefficient. And so the second part is going to be some practice on that. The question in the second part is, what is the coefficient of each of these terms? So for number 1, what is the coefficient? Do you remember coefficient? We said coefficient is the name of the number in front of the variable. It's the name of the number you're multiplying with. So in number 1, my coefficient would be this right here. My coefficient would be the number 10. Go ahead and try the rest. Number 3 and number 4 are a little challenging, but see what you come up with. For number 2, the number in front of my variable, make sure you get it all. It's all of this. It's the 12.2, but it's also the negative sign. So with coefficients, we have to pay attention to the sign as well. For number 3, I don't see a number in front of it. So I've gotten a lot of different things in class. I've gotten zeros, ones. I've gotten, there is no coefficient. It doesn't exist. To help us talk through number 3, I'm actually going to go all the way back to where we started with the S's. We had said back here that S plus S plus S, that was 3S. S plus S plus S plus S plus S was 7S. If I had S plus S, you might know that that's going to be 2S, because we're just counting how many there are. 1, 2, 3. Here there are 7 of them. Here there are 2 of them. So if I just write down S, well, how many is that? That is 1S. That coefficient, you can also think of it as it's telling you how many we have, how many you're adding. So if I go all the way back to that one we were looking at here, that X, there's no number in front of it, but I'm thinking about how many X's do I have in this problem? I have 1X. So over here, you see this box to the right. It says, if there is no number in front of the variable, the coefficient is 1. That's true for any variable. It's true for any letter. So here, my coefficient is 1. It can help a lot of people as we're first starting doing this. If you're new to this, it can help to write in that 1 when you see a variable without a number in front. And so knowing that can help us with number 4. Number 4, I also don't see a number in front of that term. This right here, our coefficient, it's similar, except this one would be -1. -1, because there's already that negative sign. And then just like this box says, I don't see a number in front of that term, so it would be the number 1. Again, this piece here is going to be really important when we get to the actual math part of combining like terms, which is coming up right now. So we said the goal for today is we want to simplify. We're continuing to work with variables. And just like everything really in math, we want to be able to simplify these math problems when we're using these letters, when we have variables. And one way we can simplify, one way we can make them look easier is by combining stuff, by adding or subtracting things. But there's a rule for what you can combine. And the rule is you can only add or subtract terms if they have 2 things in common. You can only add or subtract terms if they have the same variable. And if it helps, you can write a little reminder to yourself. We know that a variable is a letter. So they have to have the same variable, and they have to have the same exponent. It's been a few lessons since we saw that word exponent last. Do you remember exponent? Exponent is usually, I'm always doing it with my hand. It's usually that tiny little number at the top. So for example, it's something like this right here, those squares or cubes. So we're looking for that little number there to be the same, that power. We also use that word power. So when we're looking to see what we can combine, what we can add and subtract, this is what we're looking for it to have the same variable and exponent. And when they do, we call that combining like terms. This box right here at the top of the screen, this is the key idea. This is the important information for this lesson. So make sure you get this one into your notes. And this is what we're going to use to do these examples below. So we've now learned, as we look at the problems below, I can't just add or subtract every single thing in the problem. I'm looking for the same variable and the same exponent. So for example, in number 1, I see number 1 says 5x minus 2x. Before I do any math, I need to check to make sure, do they have the same variable? Yep, they do. They both have x's. And do they have the same exponent? Well, yeah, I don't see an exponent in either of them, so they're the same. We're kind of trying to look to make sure they match. It's important to say, notice that the coefficient, the number in the front, doesn't have to be the same. I'm just looking for what comes after that coefficient to be the same. So here, they're both x's, so I can do that subtraction. Now, the rest of this isn't too bad because you know how to subtract. 5 minus 2 is 3. So I know 5x minus 2x is going to be equal to 3x. And just like that, we have simplified it. There you go. You have combined like terms. Now, the rest of these, it can get a little more challenging when you have more terms in the problem. So my other 2 examples, that's what's going on. For number 2, I notice I have 1, 2, 3 terms in this problem. So just like we said before I do any math, I'm looking to see what terms can I combine? Which terms have the same variable and the same exponent? Notice in this problem, not all of them do. There's only 2 terms that are the same, and that's going to be my 2a squared and my 5a squared. And I'm going to be real careful because notice that 5a squared, it's got a minus sign in front of it. And we always want to keep the sign in front of the number. So for this problem, when I go to combine like terms, these 2 terms here in the purple boxes, that's going to be what I'm combining. And what I did here with those purple boxes can be really helpful. If you're doing this on paper, you can grab some highlighters or just use your pencil and underline or circle what those things are that you're going to combine together. It helps you focus in on which part of your expression you're working with. So I've got 2a squared minus 5a squared. In order to do the math, I'm just focusing on the coefficient. So that's the 2 and that minus 5. To get my answer, I just have to do 2 minus 5. This goes back to integers. If I'm subtracting a larger number, it's going to be negative. I've got negative 3 there. And so 2a squared minus 5a squared, that's going to give me negative 3a squared. Notice, I didn't do anything with the exponent. I didn't square anything. That exponent, that squared, is on the a. And so I'm just copying that over, just like we did up here with the x. So 2a squared and minus 5a squared combine to be minus 3a squared. Notice we're not done though. I still have this plus 2, so I need to copy that over to my answer. So I'm going to copy over that plus 2. I've got this expression here. If I look and see, is there any other math I can do? Can I add these together? You may want to, but we can't because they don't have the same variable. They both don't have a's, and they don't have the same exponent. This is a squared, and this has nothing. So this right here is my final answer. Similar to the 3x, this right here is as much math as I can do. So notice sometimes, depending on what we have, we might have multiple terms in our answer if we can't simplify anymore. This is as simple as it gets. I've got one final example, and then I'm going to have you pause the video and try some. For number 3, we're going to start out by seeing what we can combine. Go ahead and see if you can figure out what are the things we're going to add together in number 3. Well, for number 3, we've got 1, 2, 3, 4 terms this time, and we've got some options. We can add the p's together. So I see I've got a p and I've got a plus 2p. But there's something else you can also add here. Don't forget, you can add numbers together. So we're going to add those p's together, and then I'm also going to add the numbers together. I can add 1 and 5 together as well. We can start wherever we want. I'm going to start with the p's because lots of times I see students start there. P plus 2p. What did you say that equals? Well, in order to do that math, we need to use something we had said before. How many p's is this first p? What is that coefficient? I need to remember that this p right here has a 1 in front. That's going to be important so that when I add p plus 2p, maybe you're thinking in your head 1p plus 2p. That gives me 3p. And then our second part, the numbers, 1 plus 5, that gives me 6. Make sure you don't just put a 6 there. We need that plus sign to show those two terms are separate. So we get 3p plus 6. Now, can I say 9p? The answer is no. The answer is no because those are not like terms. They do not have the same variable, so I cannot add them. And this here is my final answer. Now, we said 3p plus 6 is our final answer. There is another option you might see. You might see 6 plus 3p. That is also a correct answer. That is correct because it's the same terms. They both have a 6, they both have a 3p. It's just written in a different order. When it comes to those terms, you can put them in any order you like. So both of those would be correct answers. I want to mention that in case you had the second one and was wondering if it was correct or not. So we've done 3 examples together. Go ahead, pause the video and try 1, 2, and 3. This practice is important, remember, because it's going to give you a chance to do some practice before you get to that homework and check in and see how you're doing on this topic. So pause that video now and come back to see the answers for 1, 2, and 3. All right. So for number 1, we've got 4x plus 8x. These have the same variable, so I can go ahead and add them. I can say 4x plus 8x, that is equal to 12x. So 12x is our final answer. For that second one, we have 3 terms. We cannot add all 3 of them. There's only 2 you can add. They all have the same variable, but only 2 of them have the same exponent. And that is the 2y squared and the 11y squared. 2y squared plus 11y squared, that gives me 13y squared. Again, notice I didn't do anything with the exponent. I didn't square anything. I'm just keeping my y squared in my answer. That 6y cubed I can't do anything with, so I'm just going to copy that over to my final answer and say plus 6y cubed. This right here, what we're looking at, that would be your final answer. We cannot add those together because they have different exponents. And then in our final problem, we've got, just like number 3 over here, I see 4 terms. We can combine the negative 7z and the minus z because those both are the same variable, same exponent. Be careful with your integers there. We've got a negative 7 and then minus z is, remember, minus 1z. So I need to do negative 7 minus 1. That is -8. Remember, when they're both negative, you're adding together. You're just getting a bigger negative. So -7z minus z would give me -8z. And then there in the middle, I've got two numbers I can also add. I've got a +4 and a +10. So 4 plus 10, that gives me 14. And again, if I check, I can't add these together because that's a z, that's a number. Those are different. And so that would be my final answer. And remember, you could also say, and I'll put it down as well, you could have also put the 14 first and then that -8z second. And both of those would be correct. So this first chunk here, this is what a lot of our combining like terms problems are going to look like. There's one last situation I want to look at for something that might happen in an expression when you're going to simplify. And to help us talk through this very last part, I have one last story for us. And so one last time, we're talking about saving money. I must have money on the mind. I've got Olushola saved $S this week. He went to Walmart and spent the money he saved this week. Write an expression that represents this. And then the second part says, if Olushola spent the money he saved, how much money does he have left? I encourage you to pause the video, try this problem, since this is really based on yesterday's lesson and not today's lesson. And I'm curious to see what you come up with. Come back when you've got an answer. So what I like about this problem is we already have the variable. We're using S to represent that money he saved. So I see he's starting with S dollars, and then he's spending money. When we see that word spend, if you're spending money, that math operation we're going to be using is subtraction. He's starting with S dollars and he's spending some money. How much money is he spending? Well, he's spending the money he saved. He saved S dollars and he spent the money he saved. So he spent S dollars. So I get S minus S represents the situation. He saved some money and then he spent that money he had saved. Now we've got this expression, but think about this situation. If you saved some money and then you went to the store and you spent all that money you saved, how much money would you have left? Well, if you spent all the money you saved, you would have $0. You would have nothing. If I connect that to this expression we wrote, S minus S equals 0. When you're starting with some money and then you spend all that money, we have nothing left. This idea that S minus S equals 0, though, is going to be really important when it comes to combining like terms. And it's true for so much more than just S minus S. It's true for other variables, like x minus x, that would also equal 0. It's true when exponents are involved. If I had something like y squared minus y squared, that would equal 0. It's true anytime you're subtracting the same thing. So notice all of these problems, we are subtracting the same two terms. The word you hear a lot of times is this word that these terms cancel. In this situation, the word cancel just means it equals 0. So the very last part I have for you is let's look at some expressions where we might need this information. For example, for number 10, we have this expression 5c minus 4bc plus 6bc minus 5c. If I want to simplify this expression, I'm going to approach it the same way we were doing before. I want to look and see what terms can I combine. I see there I see some C's. I see we've got a 5C and then another 5C. Be careful with those signs. The second 5C, remember I'm including the sign in front, so that's a minus 5C. So that's something I'm going to combine. And then I also have a minus 4BC and plus 6BC. Now you can start anywhere you want. I'm going to start with the 5C's just because that's what I circled first. We've got 5C minus 5C. 5C minus 5C. What is that going to equal? 5C minus 5C, that is what we just looked at up here. I'm subtracting the same thing, so that is going to equal 0. 0 is 0, so that means I'm not writing down C. C, remember, has a 1 in front. That's like me saying 5 minus 5 is 1. I don't want to say that. 5C minus 5C is 0. 0 is nothing. So I'm going to write down nothing. That's what we mean by this idea of cancel. These equal 0, and so that term with C leaves the problem. There are no more C's in my answer. And so I'm just going to write that word cancel there in green. Cancel because it equals 0. So the only type of term I have left are my BC's, this pink part right here in the middle. So I can do math with those. Negative 4BC plus 6BC, well, negative 4 plus 6, that is equal to 2. And so this expression here would equal 2BC. Again, notice there are no 5C's, there are no C's in my answer because we said that equaled 0 when we subtracted. Number 11 is for you. Go ahead and try that one now. For negative 11, for number 11, I would be on a hunt, just like we've been for all these problems, for which terms are like terms. Which terms can I combine? And for number 11, the terms that have the same variable and the same exponent are these z to the fourth powers, 12z to the fourth power and minus 12z to the fourth power. 3z is different because it doesn't have that same exponent. When we go to do this math, 12z to the fourth power minus 12z to the fourth power, that's similar to what we did up here. 12z to the fourth power minus 12z to the fourth power equals 0. Nothing. So you are writing down nothing. These cancel out. No z to the fourth powers, because remember that means 12 minus 12 is 1. We're not trying to say that. It is just, there's no more z to the fourth powers in our answer. So notice there's only one thing left. That means the only thing I have left is my 3z. And so I'm just going to bring that down, and that would be my final answer. The very last problem we have for today is number 12. I like number 12 because it's one of those questions that has a lot of correct answers. For number 12, I am asking you to write an expression that simplifies to 5x minus 2y. So what I'm asking you to do is like these problems in reverse. I'm asking you, can you come up with a problem where the answer would be 5x minus 2y? Can you come up with something more complicated, basically, where if I did the math, it would equal this? If you've got this one down, then you understand this concept. Go ahead, pause the video now and try this. Like I said, there are a lot of correct answers for this one. Maybe your strategy is to look at 5x and that minus 2y and think about ways you can get each of those numbers. For example, 5x, I could get 5x by doing 7x minus 2x. I could get 5x by doing 4x plus 1x. And I'm just going to write 4x plus x. There are lots of different ways you can make that number 5. So that's where I'm going to start. I'm going to write 2 examples, I guess. That's where I'm going to start. I've got both of those things in purple that I've written would simplify to give me 5x. Now the other thing I need is my minus 2y. Now I could go ahead and just write minus 2y. This first problem here would simplify to give me 5x minus 2y. If I simplified this problem, I would simplify the x's and combine 7x minus 2x. That gives me 5x. And then I still have my minus 2y. So that would be good. Or I could write something that would also simplify to minus 2y. So for example, I know that minus 5y plus 3y, a negative 5 plus 3, that would give me negative 2. So that would simplify to negative 2y. That's an option. I could instead, I know negative y minus y. That's like a negative 1y minus another 1y. So that would give me negative 2y. That's another option. So like I said, there are many, many correct answers for this. If you weren't able to do this one earlier, or if you just needed an example, a more visible example of what we're doing here, I really encourage you pause the video and see if you could come up with another example, because there are many, many, many correct answers. However, this is the last problem I have for you in this lesson. We are continuing this idea tomorrow of simplifying expressions. In this lesson, we talked about one strategy for simplifying is combining like terms, but there is another way you can simplify. So we are going to be learning about a different way tomorrow that you can simplify these math problems that have variables in them. So we will continue this idea of simplifying them. I hope you found this video helpful, and I will see you all tomorrow. Thanks for watching. Bye.